Hi guys. So today we're going to look at solving radical and root equations and inequalities. So we're going to start just by looking at some equations. And typically our goal here in order to solve these is to get the root by itself. Okay, except for if there's two roots, which we'll look at later. But for the majority of these, our first goal is going to be to get this root by itself. So on this first example, I'm going to start by dividing by 2. So then at this point, now that the root's by itself, my opposite operation would be to square it. So if I square the left, then I also have to square the right. So that leaves me with x plus 2 is equal to 16. So I get that x is equal to 14. Now, what's going to be very important for these radical problems is you always need to make sure you check your answer by plugging it back into the original, because some of these are going to give you extraneous solutions. All right, so if I take 14 and I plug that in, okay, I would get 2 times the square root of 16, which is 2 times 4, which does give me 8. So that does work out. Okay, so it's very important in these that we always go back and check our answers. Now looking at B, same type of problem, but this time it is cubed instead of squared, but I would still get the root by itself. And now I would cube both sides. So I'd be left with 2x minus 5 is equal to 5 cubed, which is 125. Add 5. And I get that x is equal to 65. Again, I would go back and I would plug this in. So if I plug that back in, 2 times 65 is 130. 130 minus 5 is 125. The cube root of 125 minus 2 would be 5 minus 2, which is equal to 3. So this one does work out as well. All right, so let's go and check a couple different examples. Okay, so example 2 here, similar process, but the algebra here is going to be a little bit harder. Okay, so the first thing I'm going to do again is square both sides. So this becomes 2x plus 7. And then I have to remember x minus 4 squared actually means x minus 4 times x minus 4. So when I multiply this out, I'm going to get x squared minus 8x plus 16. Now, what I'm left with is a quadratic equation. So in order to solve a quadratic, we got to set it equal to 0. And then at this point, I can factor. All right, so then I get two possible answers. I get that x is equal to 9, or I get that x is equal to 1. So my possibilities at this point then, I would plug these back into the original equation. Okay, so in the original equation, if I were to plug in 9, okay, 2 times 9 is 18, plus 7 is 25. So the square root of 25 is the same thing as 9 minus 4. Those are both 5. So 9 does work. But look what happens when I plug in 1. Okay, 2 times 1 plus 7 is 9. The square root of 9 is 3. But on the right side, I get negative 3. So that is not equal. So 1 actually is not a solution. We call that an extraneous solution. So the only answer I actually have is x equals 9. All right, similar idea here on B. Again, I would square both sides. Remember, when you square the right, you are squaring that whole binomial. So this gives us 7x plus 15. And remember, we talked about that shortcut. If you're squaring a binomial, it's square, double, square. So square, double, and square. Set it equal to 0. And then I can factor. And I get two possible answers, but I need to check and make sure they both work, or see if either one works, or see if only one works. So again, plug them back into the original. Okay, so if I plug in 7, 7 times 7 is 49. 49 plus 15 is 64. Okay, the square root of 64 is the same thing as 7 plus 1. Okay, so 7 does work as one of my answers. But if I plug in negative 2, that gives me the square root of 1, which is 1. But on the other side, I get negative 1. So 2 is an extraneous solution. My only answer here is 7. Right, so this is probably the toughest algebraic example, and it's not that it's a different process, it's just a little bit of a couple extra steps. Okay, so at this point we can't really get one radical by itself because there's radicals on both sides, and if they're not the same root, we can't add or subtract them together. So what we're going to do at this point is we're going to go ahead and square both sides. Okay, the right side, that's going to be pretty easy. That's going to be just 7 minus x. But on this left side, we have to remember we're actually doing the square root of x plus 6 plus 1 times the square root of x plus 6 plus 1. So I actually have to FOIL this out, or you could square and double and square, but I'm going to end up then by multiplying that out. I'm going to get x plus 6 plus 2 square roots of x plus 6, because it's the square root of x plus 6 plus the square root of x plus 6, and then just plus 1. And then on the right side, again, it's just 7 minus x. So then at this point, we still have a square root in our equation. So we need to go back and do what we did in the very first example or second example, where we actually get that root by itself now. Okay, so if I want to combine like terms, I'm going to have x plus 7 is equal to 2 square roots of x plus 6. So I can subtract x and subtract 7. I don't know why I wrote equals there instead of plus. Sorry about that. So minus x and minus 7. So now I have negative 2x. Divide both sides by 2. Square both sides. And remember, I'm squaring this whole thing. And when you square a negative, it just becomes positive. What I'm left with is quadratic, so I'm going to write it up here so you guys can see it a little bit better. So this is now x squared minus x minus 6. We can factor. And again, I get two possible answers, 3 and negative 2. So to test those, take that answer, plug it back into the original equation, and see if it works out. All right, so I'm going to plug in 3. So that gives me 3, the square root of 9, which is 3, plus 1, and the square root of 4. Well, the square root of 4 is 2, and 4 and 2 are not the same thing. So 3 is not one of my solutions. Okay, if you plug in negative 2, that gives me the square root of 4, which is 2 plus 1. Negative 2 over here, 7 minus negative 2 becomes 7 plus 2, and the square root of 9 is 3, so those are equal. So negative 2 is a solution, but it is my only solution. All right, now I'm going to erase this so we can work on B. Okay, so on B, it's a very similar type of problem, but it's set up a little bit differently to begin. Now, you can still get your answer if you go ahead and square your function at this point. I think sometimes it's a little bit easier to work with it the same way we saw on example A. So I'm going to go ahead and move this over. But you don't have to do that. You can just go ahead and square it from this side, and you will still end up getting your same answer. It just gets a little bit messier on some of the algebra. All right, so if I were you guys, I would go ahead and pause the video, try and work this one out on your own, and see what you get. But I'm going to go ahead and finish this one up. All right, so square both sides. So x plus 6 is 4, plus 4 square root of x minus 2, plus x minus 2. Okay, get the square root by itself. So subtract x from both sides. I would subtract a total of 2, because 4 minus 2 gives us 2. So I end up with 4 equals 4 times the square root of x minus 2. Divide both sides by 4. Then I can square both sides. So 1 is equal to x minus 2. So I get that x is equal to 3. That's my only answer. I do want to double check, make sure it works. Plug it back into the original. So the square root of 9 minus the square root of 1 is equal to 2. So that is a correct answer. All right, so the last problem we're going to look at is dealing with rational exponents. Now, we're going to solve these a very similar way. We just need to remember some of our properties of rational exponents. First thing I'm going to do is I'm going to get the part with the exponent by itself. So 2x to the 3/4 is going to be equal to 8. All right, so in order to get rid of that 3/4 as an exponent, okay, that is the 4th root of 2x to the 3rd. I'm going to use basically the reciprocal exponent, because if you do a power to a power, you multiply exponents. So this would be to the 4/3, because that would just end up giving me an exponent of 1. Well, if I raise the left side to the 4/3 power, I need to raise the right side to the 4/3 power. So 8 to the 4/3, that is the cube root of 8, which is 2 to the 4th. So I get that 2x is equal to 16 and x is equal to 8. All right, then looking at B, similar problem, similar process, get the exponent part by itself. Okay, use our reciprocal exponent, so I'm going to raise this to the 2/3. So x plus 3 is equal to the cube root of 64 squared, which is 16. So I get that x is equal to 13. All right, so now we're going to look at inequalities. Okay, so this is going to be a very similar solving process, but it has one extra step. We need to remember any even root has to be positive. So we need to include that fact when we write our solution. Now we're going to write our solutions to these in interval notation. All right, and that's just remember your parentheses and brackets with your infinities. So again, similar process here, get the root by itself. So 3 square root of 6 is less than or equal to 12. The square root of x is less than or equal to 4. Square both sides, and x is less than or equal to 16. Now that is a good part of your solution, but it's not everything, because what we also said has to be true. We know we cannot take the square root of a negative number. So whatever is under the root, in this case it's just x, you set whatever is under the root greater than or equal to 0. If you need to do some extra algebra, you do those extra steps. In this case, we're fine because it's already x by itself. But now we need to write a solution in interval notation that makes those two things true. So I think it helps sometimes to draw this out on a graph or on a number line. So I'm going to mark 0 and I'm going to mark 16. Okay, both of these would be closed circles because it is or equal to. And then I want x to be greater than or equal to 0, which is everything to the right. I want x to be less than or equal to 0, which is everything to the left. And then I just find where these two things overlap, which is this in-between spot. So my solution would be from 0 to 16. All right, now let's look at B. Okay, I would divide by 2. All right, the opposite of cube rooting would be to cube. So x plus 1 is less than 64. Get x by itself, so x is less than 63. All right, now at this point, we actually don't need to consider anything else because this was an odd root. Odd roots are okay to be negative, so there's no extra considerations. The only part of my solution is that x is less than 63, which in interval notation is negative infinity to 63. All right, let's look at our last two. Again, let's get our root by itself. So square both sides. So 5x minus 16 is less than or equal to 2x minus 4. Get all your x's on one side, all your numbers on the other. So 3x is less than or equal to 12. X is less than or equal to 4. Okay, so that is part of my solution. What also has to be true? Okay, what's under the root cannot be negative. So I would take 5x minus 16 greater than or equal to 0. I would also take 2x minus 4 and set that greater than or equal to 0 because both of those things have to be true in order for this inequality to work. So x is greater than or equal to 2. Then over here, 5x is greater than or equal to 16. X is greater than or equal to 16 over 5. So I'm going to make my number line. All right, here's 4, closed circle. 2, closed circle. And then 15 or 16 over 5 I know is a little bit more than 3, so it's going to be in between these two. Also a closed circle. All right, I'm looking for my solution to be greater than 15 over 6. I'm looking for it to be greater than or equal to 2. And I'm looking for it to be less than or equal to 4. So where all three of these line up is in this range right here. So in interval notation, my solution would be 15 over 6 to 4. All right, and then our last problem, again, the first thing is get the root by itself. So I would divide by -4. But hopefully what you guys remember when you're solving inequalities, if you divide by a negative, you flip the sign. All right, so I'm looking for this to be greater than 3. So then I would square both sides. So 2x minus 3 is greater than 9. So 2x is greater than 12. And I'm looking for x to be greater than 6. Now, it is good practice to always make sure that under our root is going to be positive. So 2x minus 3 is greater than or equal to 0. So I get that 2x is greater than 3, so x is greater than or equal to 3/2. Well, what's nice about this, if your solution is greater than 6, okay, it's always going to be greater than 3 over 2. Right, again, if you want to graph this out, here's 3 over 2, here's 6. It's greater here, and it's greater here. So everything from there over meets our criteria. So our answer here would be from 6 to infinity, and it would be a rounded bracket, okay, rounded parenthesis on our numbers because it's not or equal to.